Okay, so let's get started. The lesson that hopefully you were able to work on your own was reviewing how to solve quadratic equations. So we're going to continue to use that, but we're going to look at word problems. So we're going to do 3 examples. This won't take too long. It should be fairly quick so you can get back to practicing and reviewing for the stuff on Monday, and there was some homework and your Unit 2 portfolio. So there's tons to do. So let's get started. So for our first example here, a relief package is released from a helicopter at 1,600 feet. The height of the package can be modeled by the equation h of t equals negative 16t squared plus 1,600, where h is the height of the package in feet and t is the time in seconds. The pilot wants to know, how long will it take for the package to hit the ground? So I'm a visual learner, so it helps me a lot if I start by drawing a diagram. You don't have to draw a diagram, but it makes things significantly easier. So I'm going to draw a little graph here. We have time on the bottom, h here, and my helicopter drops it from 1,600 feet, and my little care package goes down and hits the ground. And of course, this is just a sketch, so we don't know if it's accurate or anything like that. But there are a few things we know. We know that it starts at 1,600, so that's beneficial. And we're looking for this point here. So we're looking for when it hits the ground. And if I look at that point, that is when the package is at a height of 0. So that means I can just sub in 0 for h of t. So I'm just going to write out 0 equals negative 16t squared plus 1,600, like this. So all I'm doing is just subbing in 0 for h, because when it hits the ground, we will have a height of 0. Next, let's go through and try to factor this. So that's always your next step. So step 1, make sure it's equal to 0. Next step, try to factor. So for here, I can take out a negative 16, left with t squared minus 100, like this. And now I want to continue to factor. So I have 0 equals negative 16. This is a difference of squares here. So we can just do t plus 10, t minus 10, like this. And now I can set both brackets equal to 0. This negative 16 in front, we actually don't need to worry about it because we could just divide it out on both sides, but we don't need to worry about it. So let's just set both of these brackets equal to 0. So I'll have t plus 10 equals 0 and t minus 10 equals 0, like this. And now let's solve for our t's. So for this first one, that 10 goes to the other side, so we'll have t equals negative 10. And for the other one, we're going to have t equals 10. So although we get 2 answers, only one of them is valid for this particular situation, right? My t's represent time, so we can't have a negative time. So this one here is rejected because we can't have a negative time value. So from there, we know that this is the answer that we're going to go with. So now we can just write a nice little therefore statement to sum up our answer. Therefore, the package will hit the ground at 10 seconds. Are there any questions about that first one? That first one's fairly straightforward. I'm just going to quickly go through the attendance. I just don't want to miss anybody. There we go. So are there any questions about this first example before we move on to the second one? We're okay so far? All right, let's try the next one. So for our next one, the function h at t equals negative 5t squared plus 20t plus 5 gives the approximate height h and t in meters of a thrown football as a function of time t in seconds since it was thrown. The ball hit the ground before anybody could catch it. So what we want to figure out is how long was the ball in the air for? So let's start by drawing a little bit of a diagram. Something like this. Here's my time. Here's my height. And if football is thrown, and when I have a 25 here, that represents my y-intercept. So I know here is 25, and my football is thrown and hits the ground before anybody can catch it. So what I'm trying to figure out is for how long was my football in the air. So I'm looking for this length of time here. In other words, I'm trying to figure out when did it hit the ground, because that will allow me to know how long it was in the air for. So to find out when it hit the ground, we're just going to sub in 0 for our height. So I'll have 0 equals negative 5t squared plus 20t plus 25, like this. So when we're solving a quadratic, the first thing we do is we make sure it's equal to 0. So I look here, it's equal to 0. I can move on to my next step. Second, I'm going to try to factor this equation. So the first thing I do is I common factor. So I can take out that negative 5. Like this. And now I can continue to factor the stuff in the brackets. So two numbers that add to negative 4, two numbers that multiply to negative 5. So we're going to have negative 5 and 1, negative 5 and 1, like this. And we can just put that directly into the brackets, like this. And now I can just set those brackets equal to 0. Like this. And now let's solve for our x's. So I'll have x equals 5 and x equals negative 1. So now if I think about this as a real world situation, we cannot have negative time. So if I look at my diagram here, t is definitely positive, so we have to go with this one here. And then because this is a word problem, we need to write a nice therefore statement. So we'll say, therefore, the ball was in the air for 5 seconds. And that would be your final answer. Any questions about that one so far? Hopefully this is coming back from grade 10 because you definitely did a lot of this. So hopefully it's starting to come back to the front of your brain. Okay, so for B, we're asked, for how many seconds was the height of the ball at least 27 meters? And the one thing we want to take note of here is that it says to 3 decimal places. When it's saying to 3 decimal places, they're telling us that this is not going to factor nicely. We are not going to have whole numbers, so we're probably going to have to use the quadratic formula. That word there is a nice clue to tell you that it's not going to factor, so no need to sit there trying to figure out how to factor it. So We want to figure out when the height is 27 meters. So on my graph, my ball's thrown from 25. It goes up and over like this. And at 27, it's going to hit the graph 2 times. So I want to figure out how long that time interval is. So let's figure out when the ball even hits 27. So we're going to sub in a height value of 27 meters. Now, in order to solve a quadratic, I need it to be equal to 0. So let's move this 27 to the other side. Like this. And now we can collect some like terms and simplify that 25 and 27. Like this. Okay, so now we've been told that it will not factor because it says to 3 decimal places. So we can put this right into the quadratic formula. So let's start by identifying our A, B, and C, and then plugging it right into the formula. So we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, like this. And that will give us x equals negative 20 plus or minus. Just going to do this long thing in my calculator. Minus 4 times negative 5 times negative 2 plus or minus the square root of 360 all over negative 10. And remember that plus or minus basically makes it so that this is 2 equations in one. Yes, Dimitri, you can type your question into the chat. So we'll have the first one where we add that. And that will give us a value of 0.103. So are you dividing by? So I'm not sure where you're seeing that. So I'm just going to go through and explain where all my numbers came from. So what I did first is I moved this 27 to the other side of the equation. That gave me a negative 27 here. So now I have a negative 2. 25 minus 27 gave me negative 2. And then into the equation, I just subbed in negative 5, 20, and negative 2. So in order to get this 360 here, all I did was I put this whole thing into my calculator. So I didn't do any of the splitting up terms because it's under a radical. I just simplified it. Oh, okay, perfect. So that is my first x, x1. And then we have our other x when I'm going to subtract. So x2 is going to be negative 20 minus root 360 all over negative 10. And when I put that into my calculator, negative 20 minus root 360 divided by negative 10. That will give me 3.897 seconds. So those are the 2 points at which it reaches 27 meters high. Now it's asking us for how many seconds was the height of the ball at least 27 meters. So I'm sorry, it's kind of getting messy. I'm running out of room here. So in order to find out the length of time it was above there, we're just going to do 3.897 minus 0.103. So I get 3.794. So therefore, the ball was above 27 meters for 3.794 seconds. So again, how I got 3.794 was I subtracted the two numbers from one another. Why did I subtract? Because I'm trying to figure out the length of time that it was above here. I'm looking for this length of time. So I need to figure out the difference between those two times here. That's why. So I'm looking for the difference. So this here would be 3.897 seconds, and this here would be 0.103 seconds. All right. Any other questions before we move on to the last one? Last one's a little bit tougher, but I think that we can all handle it and we'll be okay. All right. Just to make sure everybody has a moment to write that down, I'm just going to do a last minute attendance just to ensure that I have everybody marked down as here and I don't accidentally make a mistake. There we go. All right. So this last example is a little bit different. We're not looking at the motion of a ball. We're looking at area. And very often area questions are also quadratic questions, right? With area, we usually have units that are squared. So it makes sense that I have a quadratic somewhere in there because I have squared values. So for this example, a preliminary floor plan for a new house includes a rectangular dining room that measures 5 meters by 4 meters. So let's draw that out. We have a little rectangular dining room here, and it's 5 meters by 4 meters like that. The customers want a larger dining room and agree to an area of 25 meters. So the architect decides to redesign the floor plan by adding a strip of floor uniform width to 2 adjacent sides of the dining room. So we're going to add some floor here, and we're going to add some floor here, like this. Now, oops, go back to here. How wide should the strip be to the nearest thousandth of a meter? So nearest thousandth means 3 decimal places. So again, that's telling us we're going to have to use the quadratic formula. So all of our little strips here are the same width. So that's x, this is x. So to start, let's figure out the dimensions of the bigger rectangle. So from here to here, we're going to have 5 plus x. And then from here to here, we're going to have 4 plus x. So again, to clarify, we'll have 5 from here to here, plus the x of the width of the new strip of flooring, and then we'll have 4 from here to here, and then we'll have an additional x from the strip of flooring there. The other thing we know is that the area of the big rectangle is 25. So let's start to figure out the equation. So we have a rectangle, so my area is going to be length times width. We know that the area of the big rectangle is 25 meters squared. The length is going to be 5 plus x, and our width is going to be 4 plus x, like that. If you swapped your length and width, it doesn't matter, you'll get the same answers. So now let's go through and solve this equation. So the first thing we need to do is we need to get this thing equal to 0. And if I were to bring over the 25 now, it would be really hard to collect like terms. So what we're going to do is we're going to multiply out the brackets first. So remember to draw the arrows so that you don't accidentally miss any multiplication. So now we have 25 equals 20 plus 5x plus 4x plus x squared. Now we can bring that 25 over to the other side so that it equals 0. And I'm just going to reorder this a little bit because the order matters with how we put it into the quadratic formula. All right. So now I'm just going to collect some like terms. And now we can get to solving. So similarly to the last one, it says that we're rounding to the nearest thousandth of a meter. So that's telling you that this does not factor nicely. So we don't even need to bother trying to find these numbers. We can jump straight to the quadratic formula. So let's label our coefficients. We have A, B, and C, and we can just sub these right into the formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Like this. Now I'm just going to simplify all that stuff under the square root sign. So 9 squared minus 4 times 1 times negative 5. And we'll get 101. So we have x equals negative 9 plus or minus the square root of 101 all over 2, like this. Now, because of that plus or minus, this is actually two equations in one. So I'm just going to separate them. So if x equals negative 9 plus root 101 over 2, and we have x equals negative 9 minus root 101 all over 2, like this. And I'm just going to simplify those in my calculator. So we'll have x1 is equal to negative 9 plus root 101. We'll get 0.525 meters. And for x2, I'm just going to put that into my calculator because it's going to be a funny decimal, so it's kind of hard to do in my head. Minus root 101 divided by 2. And we're given negative 9.525. Now, if I look here, one of these answers I can't use. And that is going to be this negative 1. And the reason that we reject it is because we can't have a negative length. So that one is rejected because we can't have a negative length. So what that means is that the x value we're looking for is 0.525 meters. So we can say, therefore, the width of the strip is 0.525 meters, like this. And that is our final answer. Are there any questions? Because that's our last example. a moment to ask some questions. So sometimes we can have two answers. This is actually a really good question. So sometimes that happens with a word problem that both my answers are correct. And sometimes I also don't get a negative answer. Sometimes it results in even two positive answers. And that's okay. So you can have two valid answers for this. Typically with the area ones, one will be negative, so you can get rid of it. But similarly to above, here, how if I had just asked you, when does it reach 27 meters, you would have two answers for that are valid, and that's not a problem. So if they both work in the context of the situation, then two is fine. You can always have two answers. So if an area question has two positive ones, and I go up and I look at my diagram here and it makes sense within the diagram, yeah, we could have that for sure. You won't see a lot of it, to be honest. Typically your answers, you'll get one positive, one negative, but certainly not impossible. There could be two options maybe for a rectangle to be added or something like that that would still result in the same area. So it's likely. It could happen. What are quick feedback for the quizzes? So I'm just going to quickly stop the recording because it's just going to get really